Hello everybody, this is Mr. Bowman. So today we're going to be looking at ways you can find distances on the coordinate plane. So not the one-dimensional number lines that you've seen before, but actually the full XY two-dimensional Cartesian plane. Okay. So there's two main ways to do it. If you know the distances already, so say I'm going from this point to this point, and the distance we're trying to find is that one that connects them together, right? So sometimes you can either by counting, or sometimes it's labeled, you can count what these are and make a right triangle. Okay, and that's the easier scenario. So if that's the case, so say we know this one is 3 and this one's 4, I can find that distance by using my Pythagorean theorem, okay, which is a squared plus b squared equals c squared. Okay, it's a relationship between right triangles that relates all three sides, or specifically the length of all three sides together. So the key to this one is C has to be the longest side. It's the one that's opposite your right angle. Okay, so you start at your right angle, it's the one that doesn't touch it. So this one has to be C. The other two don't really matter that much. You can call this one A and this one B, or this one A and this one B. It doesn't really matter because those are the legs of your triangle. So the legs are going to be A and B. Okay, and the long side, which is called your hypotenuse, is C. Okay, so as long as you keep those straight, it should work out really well for you. Alrighty. So as I plug these in, I'm going to go ahead and make 3A and 4B, but like I said, it doesn't really matter. So plug that in. 3 squared plus 4 squared equals, I called it x originally, so I'm going to change it to x squared here. Then I'm just going to simplify it down. So 3 squared is 9, 4 squared is 16, equals x squared. 9 plus 16 is 25. I don't want x squared, I do want x, but notice when I take the square root here, normally we get plus or minus 5, but I don't need the negative because I'm talking about a distance, which we decided earlier is going to be an objective positive number. Okay, so I only need the positive root there. So in this I find my distance here is 5. So if you know both the lengths, you just use this Pythagorean theorem, and you can work it out that way. Now, if you don't, if you have the coordinates instead, you're going to use something that is derived from the Pythagorean theorem, but looks a little bit different. It looks a little bit more chaotic. So it looks like this. And it is known as the distance formula. Okay. So, but what it is if you take 2 points, let's go with the same similar setup here, but instead of knowing the lengths, I'm still trying to find this distance. I'm calling this one, say, x1, y1, so for generic components there, and this one x2 and y2, meaning the x component from point 1 and the y component from point 1. And this one is the x component from point 2 and the y component from point 2 as well. So if I do that, I still am using that Pythagorean theorem setup, but just like when we had that one-dimensional breakdown from the number line distances, how do we figure out how far this line is? Well, we took the two coordinates and subtracted. So in this case, this bottom one would be x2 minus x1, because those distance here, the horizontal distance, is by the x component. And here, I'm talking about how much we're changing vertically. So that would be y2 minus y1. So subtracting my y components. Then, if you plug those into the Pythagorean theorem, you end up with this formula, except for it's usually d squared, but they wanted d by itself, so they just took the square root there. Okay. Now, how to actually do this is, what if we have points at 6, 3 and 2, 1, perhaps, something like that. So what I want to do first is I want to decide which one is 0.2 and which one's 0.1, and it does not make a difference. Just make sure you write it down so when we plug things in, we plug them into the right place. So I'm going to call this one, just because of how I wrote them, I'm going to call that one 0.1, and I'm going to call this one 0.2. So in my distance formula, looking up here, d equals the square root of x2. So I need the x component from 0.2. So 2 minus x1, which is 6 squared, plus y2 minus y1, so 1 minus 3 squared. After I plug everything in, and this is the most finicky step, so make sure that you are careful plugging them in. After that, it's just cleaning things up with your order of operations. So 2 minus 6 is negative 4. 1 minus 3 is negative 2. We're leaving the squareds, which is going to be my next step. Negative 4 squared is positive 16. Negative 2 squared is positive 4. Add these up. 16 and 4 is a total of 20, which usually we want to clean that up. So break that down, you'll find out that it's equal to 2 radical 5. Or if you're looking for an approximate answer, you can plug this into your calculator and get a decimal equivalent as well. So you have two setups. If you know the distances, you can go straight to the Pythagorean theorem. If you don't, usually you'll want to use this distance formula and work through it that way.